Think about the ideal security robot. You want something that can patrol a perimeter, check corners, and respond to threats without human intervention. In theory, this sounds simple. In practice, the ground is rarely simple. Most security environments are not perfectly flat concrete. They have stairs, debris, rubble, and uneven surfaces. This is where the engineering challenge lies. How do you build a machine that is fast enough to be useful but robust enough to handle the chaos of the real world? For years, the robotics industry has leaned heavily on two distinct approaches. The first is the wheeled robot. These are efficient, stable, and can move quickly on flat ground, but they are helpless against obstacles. A wheeled robot cannot climb a flight of stairs or hop over a pile of bricks without external assistance. The second approach is the quadruped, the four-legged robot. These can navigate rough terrain with impressive agility. However, they come with a massive penalty in complexity and power consumption. Every leg requires multiple motors, sensors, and a complex control system to maintain balance. This makes them expensive, heavy, and difficult to deploy for simple tasks like perimeter defense. There is a third option that sits somewhere between these two extremes. It is a design that emerged from research at the Swiss Federal Institute of Technology, often referred to as ETH Zurich. The robot is officially named Ascento, though it is frequently discussed in the context of security applications, sometimes labeled as the Ascento Guard. The distinction matters because it highlights the specific engineering intent. This is not a general-purpose exploration bot. It is a specialized system designed to merge the speed of wheels with the obstacle clearance of a jumper. Here is the thing about Ascento. It does not use legs in the traditional sense. It does not have 4 or 6 articulated limbs that swing to lift the body. Instead, it uses a compact two-wheeled chassis that incorporates a jumping mechanism. The core innovation lies in the suspension system. Engineers utilized a 4-bar linkage connected to torsional springs. Think of it like a high-performance bicycle suspension, but scaled up and integrated into the drivetrain. When the robot needs to move, the wheels provide propulsion. When it encounters an obstacle, the springs compress and release, launching the robot into the air. This approach solves a fundamental problem in robotics called power density. A quadruped robot needs to constantly power multiple joints to keep its center of mass stable. A wheeled robot needs no such power, but it needs a clear path. Ascento uses the energy stored in its springs to handle the vertical movement. This means the motors do not need to work as hard to lift the weight. The result is a machine that can move faster than a legged robot and overcome obstacles that a wheeled robot cannot. Now consider the security context. Why does this matter for perimeter defense? Imagine a warehouse or a factory floor where a robot is tasked with patrolling at night. If a forklift has parked in a corner, or if there is a pile of pallets blocking a hallway, a standard wheeled robot is stuck. It can roll around the obstacle, but it cannot get through it. A quadruped could climb over, but it would consume significantly more battery power to do so, limiting its patrol duration. Ascento offers a middle ground. It can roll at high speed along the open floor and then hop over the obstruction to continue its path. This keeps the robot mobile without draining its battery on complex legged locomotion. The design philosophy here is rooted in bio-inspired mechanics. The team behind the project, including Victor Clem and Roland Siegwart, drew inspiration from how animals move energy efficiently. By using springs, they store potential energy and release it quickly. This is similar to how a kangaroo moves or how a pogo stick works. The mechanical simplicity is a feature, not a bug. Fewer motors mean fewer points of failure. For a security robot that needs to operate autonomously for long periods, reliability is just as important as agility. However, no engineering solution is without trade-offs. While the hopping mechanism is brilliant for locomotion, it comes with limitations regarding manipulation. The robot has a single degree of freedom in its legs. This means it is not designed to pick things up or interact with the environment in complex ways. It is a mobile platform, not a manipulator. If the security task requires opening a door or handling a package, this robot is not the tool for the job. It is strictly for navigation and observation. There is also a nuance in the naming that researchers often debate. While the academic paper from the International Conference on Robotics and Automation refers to the system as Ascento, the industry sometimes adds the guard suffix to emphasize its security role. This is not a different model variant. It is the same machine, viewed through the lens of a specific application. Confusion sometimes arises when comparing it to other projects, such as the DI-ABLO robot, which is a 6 degree of freedom system from different research groups. It is important to distinguish these designs to understand the specific niche Ascento occupies. Ultimately, this technology represents a shift towards specialized, cost-effective autonomous solutions. It suggests that for many security tasks, you do not need the full complexity of a quadruped. You do not need a robot that can walk on all fours. You need a robot that can get where it needs to go. By combining wheeled efficiency with a jumping actuator, the ETH Zurich team has demonstrated that high-speed mobility and obstacle negotiation can coexist in a compact package. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.